Dear students, welcome to the world of chemistry. Chapter 4, Chemical Bonding and Molecular Structure. This is the e-content lesson number 10. Learn chemistry in a simple way. Have you enjoyed chemistry? Yes, learn well. Today we will learn about an important topic, hybridization. The concept of hybridization can be understood by following analogy. See the color of paint. One can contain white paint. The other can contain red paint. If we mix two cans, what is the color of the paint? Is it white? Is it red or any other color? Yes, of course, the other color is formed, that is pink is formed. When we mix one bottle of white and one bottle of red, how many bottles of pink is obtained? 2 bottles or cans of pink is formed is equal to number of bottle or can mixed. That is one color white paint and other pink paint. When we mix one bottle of white paint and one bottle of pink paint, we will get 2 bottle of pink is obtained. That is number of pink formed is equal to number of bottle mix. Yes, pink is formed, that is 2 pink bottle is formed is equal to number of can mix, that is 1 white paint and 1 red paint. It is known as hybrid. New pink is formed is known as hybrid. The process is known as hybridization. Likewise in chemistry, when we mix atomic orbital, that is s orbital which is spherical in shape and 3p orbital which is dumbbell in shape. When we mix one s orbital and 3p orbital to give 4 sp3 hybrid orbital of same shape and same energy is known as hybridization. Yes, can you predict the shape of hybrid orbital while mixing 2s orbital and 3 2p orbital, that is 2px, 2py and 2pz orbital? See the slide. 2s orbital is spherical and 2p3 orbital is dumbbell in shape. What shape of hybrid orbital is formed? The hybrid orbital has electron density concentrated on the one side of the nucleus, that is one lobe has larger than the other, that is one upper lobe and one lower lobe. It is hybrid orbital. Yes, who proposed the term hybridization? Yes, Linus Pauling in 1931. What is the term hybridization? Can you define the term hybridization? Hybridization is the process of intermixing of pure atomic orbital of slightly different energies and shape to form new hybrid orbitals of same energy and same shape. Can you give the salient features of hybridization? See the salient features of hybridization. Hybrid orbitals have same energy and shape. The number of hybrid orbital formed is equal to number of atomic orbital mixed. Hybrid orbitals are effective in forming stable bond than pure atomic orbitals. Hybrid orbitals are directed in a space in some preferred direction and have stable arrangement. Hybridization gives the geometry or the shape of the molecule. These are the salient features of hybridization. What are the possibilities of hybridization of s orbital, p orbital and d orbital mixing? What type of hybridization is formed? When we mix s orbital, p orbital and d orbital? Yes, sp3 hybridization, sp2 hybridization, sp hybridization, sp3d hybridization and sp3d2 hybridization. Then first we can study what is sp3 hybridization. See the slide. Here one 2s orbital and 3 2p orbital, atomic orbital intermixed to form 4 sp3 hybrid orbital known as sp3 hybridization or tetrahedral hybridization. See the shape of 2s orbital and 2p orbital. The 2s orbital is spherical in shape and 3 2p orbital, that is 2px, 2py and 2pz preferred in the direction of x, y, z directions. That is 4 atomic orbital, that is 1 2s and 3 2px orbital intermixed to form 4 sp3 hybrid orbital. We get a 4 sp3 hybrid orbital and one having larger lobe than other lobe, that is upper lobe and lower lobe. Can you give an example? Methane. Methane, that is in the carbon, the central atom is carbon. In the ground state, the carbon atomic number 6. Then subshell wise electronic configuration is 1s2, 2s2, 2px1, 2py1 and 2pz0. Here the carbon central atom has only 2 half-filled atomic orbital. So carbon in the excited state, one 2s orbital is promoted to 2pz1. That is the subshell wise electronic configuration is 1s2, 2s1, 2px1, 2py1 and 2pz1. That is 4 half-filled atomic orbitals of carbon overlap with the 1s orbital of hydrogen atom to form 4CH sigma bond, that is overlapping along internuclear axis located at the corners of regular tetrahedron. The hybridization is sp3. The shape is tetrahedral. What about the bond angle of methane? Bond angle of methane is 109 degree 28 minutes. It is rounded as 109.5 degree. Then we pass on to what is sp2 hybridization. What is trigonal hybridization? Can you give an example? Yes, in ethene or ethylene. What is the structure of ethylene? See the slide. CS2 double bond CS2. Here one 2s orbital and 2 2p orbital in 2px and 2py orbital intermixed to form 3 sp2 hybrid orbital known as sp2 hybridization. See the slide. 2 hybrid orbitals of each carbon atom overlap with the 1s orbital of hydrogen atom to form strong CH sigma bond. And the third sp2 hybrid orbitals of each carbon atom overlap with another carbon atom to form a strong CC sigma bond. The pure pz orbital of each carbon atom overlap laterally to form a 2 pi bond. See the slide. 2 hybrid orbitals of each carbon atom overlap with the 1s orbital of hydrogen atom to form a strong CH sigma bond. The third sp2 hybrid orbitals of each carbon atom to form strong CC sigma bond. The pure pz orbitals of each carbon atom overlap laterally to form a pi bond, that is perpendicular to internuclear axis to form a pi bond. Thus, double bond in ethene made up of how many sigma bond and how many pi bond? It consists of 1 sigma bond and 1 pi bond. What is sp hybridization? Give an example. Yes, acetylene or ethane. What is the structure of ethane? CH triple bond CH. Here one 2s orbital and one 2px orbital intermixed to form 2sp hybrid orbitals known as sp hybridization. That is in sp hybridization, that is in ethane, 2 CH sigma bond, 1 CC sigma bond and 2 CC pi bond. Here 2 2py and 2 2pz orbital lateral overlap to form pi bond, that is perpendicular to the internuclear axis. These are the hybridization of ethane molecule or methane molecule, that is single bond, that is sp3 hybridization. In ethene or ethylene, that is double bond, it is sp2 hybridization. In ethane or acetylene, that is triple bond, it is sp hybridization. We can study easily about organic chemistry, that is methane, ethane, ethene or ethylene or acetylene or ethane. Hybridization can be studied very easily. In a single bond, sp3 hybridization, in a double bond, sp2 hybridization, in triple bond, sp hybridization. Then we can do an assignment. Explain the hybridization of PCl5. Taking phosphorus as the central atom. What is the atomic number of phosphorus? 15. Write the subshell-wise electronic configuration of phosphorus in the ground state. 1s2, 2s2, 2p6, 3s2, then 3p3. So, phosphorus in the ground state is represented as 3s2, 3px1, 3py1 and 3pz1. Only 3 are filled orbital. So, phosphorus in the excited state, one of the 3s electron can be promoted to 3d orbital, that is the vacant 3d orbital. So, the subshell-wise electronic configuration is 3s1, 3px1, 3py1, 3pz1 and 3d1. That is 5 are filled orbital. That is the hybridization is sp3d hybridization. That is 5 are filled orbital intermixed to form 5 hybrid orbitals, that is 5 chlorine atom, that is sp3 hybridization. Shape is trigonal bipyramidal in shape. The bond angle is 90 degree and 120. In the similar way, we can explain the hybridization of sulfur hexafluoride. The central atom sulfur, what is the atomic number of sulfur? 16. Give the subshell-wise electronic configuration of sulfur. 1s2, 2s2, 2p6, then 3s2, 3p4. So, sulfur in the ground state can be represented as 3s2, 3px2, 3py1 and 3pz1. And 1 electron of 3s orbital and 1 electron of 3px orbital can be promoted to 3d orbital, getting hybridization sp3d2 hybridization. The shape of SF6 is octahedral in shape. The bond angle is, all the SF bond are in bond angle 90 degree. You have clear idea about the term hybridization and the type of hybridization. We have learned sp3 hybridization, sp2 hybridization, sp hybridization, sp3d hybridization and sp3d2 hybridization. Learn these hybridization well. Thank you all. We will meet the next content lesson 11. Thank you.